Hello, welcome to the presentation. My name is Shirgupe, PRN 215100026. This is presentation for system testing ISE-2. The topic of today's presentation is Pytest, which is a Python testing framework which is widely used for a lot of different testing and in multiple scenarios. Firstly, let's start with what is Pytest. Well, Pytest is a powerful and versatile Python testing framework designed to make testing easier and more efficient. It allows you to write tests using standard Python syntax, making them more readable and maintainable. Its key advantages are it's simple and its high readability, its simplicity and readability. It's very extensive and it has a robust plugin ecosystem. It also offers a large number of features out of the box, like parallel execution and dependency injection, and many more features like that. It's also compatible with the existing unit test framework, which is provided by Python. So you can think of it as a modern, flexible, and highly extensible alternative to the built-in unit test module. Now, the core concept of PyTest is test functions. So, what are test functions? Test functions are basically the way in which you define tests in PyTest. For every test, we write a Python function, a normal Python function, with only condition being that it should be prefixed with test hyphen, like test underscore, for PyTest to discover these things. Assertions are key over here. We use assertions to perform our tests, and there is no need for classes, at least initially. Later on, we could have them for organization purposes, but PyTest doesn't impose any requirement for classes unlike unit tests. So this reduces the boilerplate code. Let's look at an example. Uh, so we can see over here two tests. The first test is this function test addition. So a function defines a test. The test underscore tells Pytest that when we run this file with python3-m pytest, your file name, Pytest will go in and discover all the functions that are prefixed with test underscore and treat them as tests, and it will run them as tests. So it will run this function result equal to 2 plus 2. Then it will look at the assert statement, result equal to 4. If yes, then this test passed. If no, this test will fail and will get this message, expected 2 plus 2 to equal 4 but got the other result. So basically PyTest involves writing a function and performing certain operations inside function, and then ensuring that our logic is correct with the help of assert statements. And if it fails, then we also give a helpful message which will help us debug where exactly things went wrong. We could see a similar function over here, just with strings rather than integers. PyTest also defines a very powerful feature which is called fixtures. Fixtures are a powerful feature for managing test setup and teardown. So many times it happens that we have certain resources, like say server connection or DB connections, and we want to perform tests that involve using these connections. Then normally we would have to like repetitively set up these connections, perform our tests, then tear down these connections. Maybe we could do it in a for loop, but then there can be connection failures and all these things. So PyTest actually provides a very simple and easy way to deal with these problems, and that's PyTest fixtures, which can be defined using decorators. Let's look at an example. Say we have a test and we want to run a test on an SMTP server. Now usually you would have to start SMTP server with this SMTP lib and then run your test, and after they are done, then we can quit that thing. So your usual code would look like a lot of for loops, while loops, and if conditions in here. With PyTest, we just define a PyTest fixture, which is nothing but a simple PyTest function which sets up this SMTP server, yields it, which will basically provide it to anyone that's going to use this SMTP server. Once they are done using it, this yield will return and it will go on and quit this. So let's look at how this fixture will be used. Say you want to test sending an email. We write a normal PyTest and define an argument which is SMTP connection. We don't tell where it's going to be passed. We just ensure that this SMTP connection matches the name of the fixture name. and we write our test assuming that we have got that SMTP connection object. Now when we run this file, Pytest will look at this SMTP connection, it will look at this fixture and decide that okay, this arguments needs to be filled with this fixture. It will evaluate this function, and at any point where it yields something or returns something, it will take that value and use it as an argument over here. So basically our test send email will be using the argument that's yielded by this function. Once it's done using it, it will return, and then this yield will also return, and our SMTP server.quit will be called. So basically we have dealt with entire establishment and cleanup inside a single function with Pytest fixtures, and we also have a very simple way to pass it to other tests. Pytest also provides a very important feature, that is marking, which allows us to categorize and filter tests. So marking can involve skipping test upon certain conditions, or parameterizing test. To understand more about markers, let's look at a few examples. So let's say we have a certain test. Now in this case it's a very small test, but it may be a very big and complex test, and it's failing due to some reason. So we want to skip that test for now, for the time being. Then we could use pytest @pytest.mark.skip and write the reason for this thing, and our test would be skipped whenever we run python 3-m or file name. So that allows us to skip our test. Or maybe our test runs under certain conditions only. Maybe there are certain environment variables, or only on certain platforms can we run this test. In that case we can use python.mark.skipif condition, which will basically evaluate whatever we give, whatever boolean expression we give as the first argument. If it's true, it will execute this test. If it's false, then it will use this reason and say that we are skipping this test, and the reason is this reason that we have given. For over here it's that this test runs only on Linux. We can also parameterize our test. So let's just say that you have written a single test. You want it to run with multiple different parameters. Now the same test but different parameters. In that case we can use pytest.mark.parameterize, where we first define how many parameters we are going to give it. In this case it's input string and expected output, 2 parameters. Anything after that, that would be treated as a fixture, and will try searching for fixtures for that. After that we define a list of tuples, where each tuple will be a set of parameters, and Pytest will take each of these tuples and run our entire test for this tuple. So it will run once for hello, it will run once for world, it will run once for Pytest. So there are 3 tuples, so the test will run 3 times. So it's equivalent to 3 different tests, like 3 similar tests with different parameters, which evaluates to 3 tests in total. So in conclusion, why choose Pytest? The major reason is its high readability and simplicity. It's very easy to write Pytest test. Then its powerful features, fixtures, parameterization, marking, auto discovery. Then there's also its extensive plugin ecosystem. Pytest integrates very easily with a large variety of environments and libraries. It's also highly flexible because mostly we are only using Python functions, so it's very easy to adapt or test to different situations compared to something like unit test, where you strictly have to write a class and you have certain expectations. There's also a very large and active community support for Pytest, and there are many new initiatives that keep coming up. Also, Pytest really leads to very high improved productivity, because you can write your test quickly, easily, and execute them very easily. Maintaining dependencies is easier, and tests are self-contained. In conclusion, Pytest empowers developers to write effective and maintainable tests, leading to more robust and reliable software. Thank you.